Welcome back. We're going to begin with reviewing, starting with solving just quadratic equations that have no b term. And the reason that this is important is because this time we're actually going to get into quadratic equations that have the b term and how you solve those. So remember, if they do not have a b term and it was something like 3x squared minus 4 equals 7. Well, it's all the same as just adding equations. So we get 3x squared equals 11, divide by 3. So we get x squared equals 11 divided by 3. And then you take the square root, and it's very, very, very important that when you write your answer, you put plus or minus in front. And in this case, because I can't reduce this and I cannot take the square root without it being a crazy long decimal, you can just leave your answer as it is right here. Factoring. Remember when you do your table. Okay, so the table and then replace the middle term, group, GCF, and then regroup. Okay, so remember all that. I am going to do an example problem with you, but if you need to review it, if you need a more intense review, then you need to go back and watch those videos. Okay? So, moving along, this section 4, factoring to solve quadratic equations. First thing we have is zero product property. And basically what that says is if a times b equals 0, then either a is 0 or b is 0. Which makes perfect sense. The only time that you can multiply two numbers, so 4 times 0, the only way you can get the product to be 0 is if one of those terms is 0. It doesn't matter which one as long as one of them is. If I flipped it and made it 0 times 4, I'm still getting 0 as a result of that. Okay, so if it was 0 times b, that would be 0, or if it was a times 0, that would be 0. So we have several options on how to get 0. Oops, wrong way, sorry. Okay, so using that zero product property, think of this first binomial right here as your a term, and the second binomial right here as your b term. Well, if this first one was equal to 0, and we were able to make this first set of parentheses equal to 0, we would have 0 times x minus 2, in which case it would just be 0, because we know 0 times anything is 0. So if we subtract 3 from both sides, we get x is negative 3. Okay, so there's one answer. If we put negative 3 in, and I'll write it right underneath here, negative 3 plus 3 times negative 3 minus 2. Well, if you look at this first set of parentheses here, you end up getting 0 times negative 5, which is just 0. Okay? But now we aren't done because there is a second set of parentheses. So I'm going to go ahead and erase this. And now we're going to deal with our b binomial. Okay, so we can also take x minus 2 and set that equal to 0 as well. So add 2 to both sides, and we get x equals 2. So again, we can go and check this. If you put 2 in here for x, and also here, what you would end up getting is 5 times 0, which is 0. So we actually have two solutions. Okay, so two solutions. One of the solutions was x equals negative 3, and another solution was x equals a positive 2. Plugging these in one at a time, so not putting in negative 3 for one x and 2 for the other one, but putting in negative 3 all at once and then putting in 2 all at once will result in the 0 as your answer. Okay, so don't worry guys, we got this. Alright, so remember each set, binomial 1, A, binomial 2, B. So 4x plus 1 equals 0. Solve your equation. So you get 4x equals -1, divide by 4, and you get x is a -1/4, and it's fine to just leave it as a fraction. So there's one answer. And now repeat that, but with our second set, x minus 2 equals 0. So we add 2 to both sides, and we get x equals 2, and there is a second answer. So those are our two solutions. And remember that the solutions are also zeros. And remember those are the same as roots or x-intercepts. Woo! Okay, so now you're probably wondering, okay, so when do I factor? When don't I factor? To factor or not to factor? That is the question. Okay, so factor to solve these. If you have something like this, you do not factor this. Factor to solve something like this. But you do not factor an equation that would look like this one. Are you seeing why, perhaps? Maybe it might have something to do with this. Huh? Maybe. Well, guess what? It absolutely does. So you use factoring when an equation has a squared term and a variable or a term with one variable, and that would be exactly correct. And you can't see this part, but that is precisely and exactly together. Anyway, if we come back here, what do you notice? It has x squared and x. Over here, only x squared. Alright, so here we have an a and a b term. Over here we have a, but no b. Alright, and this would even be, you would even factor if you had an a and a b, but let's say your c was something like 0. Even still, you would factor to solve those. Okay? Alright, so let's go ahead and factor. Remember how to do this? Multiply first and last terms. So multiply to give you 10, add to give you 11. I'm going to go through this kind of quickly to save some time, so if you need to review it, you need to either go back and rewatch the video or look in your notes or something. Factors of 10 are 10 times 1. When we add 10 and 1, we get 11. So what that means is we are going to replace our middle term right here with our two numbers from here. So replace. So we get x squared plus 10x plus x plus 10 equals 0. Remember, now we do our grouping. So group your first two, last two, put the plus sign in between, so it should look like x squared plus 10x plus x plus 10 equals 0. Take out your GCF, so x is the only thing that these two have in common, leaving you with x plus 10. In this case, they don't have anything in common, so our GCF is 1. And now we group our GCFs, x plus 1, and our x plus 10. Okay, so now we have factored these. And now we use our zero product property to solve. So we set one set of parentheses equal to 0, subtract 1 from both sides, so x is -1. So there is one solution. And then we set our second set of parentheses equal to 0, subtract 10 from both sides, and we get x equals -10. There is our second solution. Okay, you got it? I know it was kind of quick, huh? But now with this example, you're thinking, wait a minute here. That's not equal to 0. And what have you noticed? Well, in this problem, it was equal to 0, and that's why we could solve these. Same with here. But what we also know is when we're factoring, it needs to be in standard form. So put it into standard form first. Okay? So if it has an x squared or a w squared and another variable, standard form first. So we would do that by adding 12 to both sides. So we get 2w squared minus 11w plus 12, and now we have it equal to 0. Now we can factor and solve. So multiply to get 24, remember that is 2 times 12, and then add to get negative 11. In this case, if we took a negative 8 and multiplied it by a negative 3, we would get a positive 24 when we multiplied them, but if we added negative 8 and negative 3, we would get negative 11. So now go and replace your middle term, 2w squared minus 8w minus 3w plus 12 equals 0. Regroup, leave your parentheses, or leave your signs inside the parentheses, put a plus sign in between. Remember, that's very, very, very important that you put a plus sign right there. Take out your GCF, 2w, leaving you with w minus 4. Now here, remember when this term is negative, we take a negative out, negative 3, and when we do that, we're left with w minus 4. Alright, and then for the next step, group together your GCFs, 2w minus 3, and multiply that by what was left over, w minus 4. And now we're solving. Since we have factored, we solve, so 2w minus 3 equals 0, and w minus 4 equals 0. Well, in this first one right here, I guess really it's the second one, isn't it? You get w equals 4, so there is one of your solutions. In this answer, when we add 3 to both sides, I'm going to move over here just because we have some more room. We get 2w equals 3, divide by 2, and w equals 3 over 2, 1.5, however you want to write it, and there is your second answer. So those two are your zeros, your roots, your solutions, whatever you want to call them. Okay? But now this one has no C term, and you're thinking, oh my gosh, what do I do? If there's no C term, all you can do is take out the GCF. That's it. So what do these both have in common? Well, we can take out a 3, right? And we can take out an n. So we're left with negative 2n, and then plus 5. Well, again, even though this isn't written here, this is just a number times a number, right? So we have 3n equals 0, and negative 2n plus 5 equals 0. So even if we divide by 3 right here, we still end up with n is 0. That is a solution. Okay, so don't assume just because it's 0 that it doesn't work, or that it's, no solution or whatever. As long as it's a number, we are good to go. Now, when we subtract 5 from both sides, we get negative 2n is negative 5, divide by negative 2. Remember that negative divided by a negative is a positive, so we get a positive 5 over 2. So there are your two solutions. Okay, so no C term, only factor out GCF. Okay, that's it. That's all you have to do. Alright, large numbers. Oh my gosh! You don't want to do that, do you? Actually, you know what? I think I'm going to do you a big favor and do this with you in class. Okay, so I'm going to skip that for now. The 3 solutions, I think I will do that with you in class also. But what do you notice first with all 3 of these numbers is that they each have a p term, and that has something to do with the fact that there are 3 solutions. It's very, very important. Okay, so these last 2 problems here I will go ahead and do with you in class, and then we'll kind of see how it goes from there. We are almost done with Chapter 9. We're almost done making our way through this quarter. You guys are getting smarter and smarter by the minute, so I guess it is time to stop.
You can't touch this. You can't touch this. You can't touch this. You can't touch this. My, touch this.